Hi, I'm Patrick Reagan. This video, TCP/IP Part 13, Introducing DNS, is the first of 4 videos that will discuss DNS in detail. DNS is one of the background services that's the critical linchpin service that is used by everyone, and if it's down or misconfigured, it can significantly impact the function of other services in the internet as a whole. This video covers host files, DNS name resolution, forward and reverse lookup zones, root name servers, recursive and iterative DNS queries, authoritative and non-authoritative DNS server, DNS zones, DNS forward and reverse lookup zones, and DNS caching servers. If you liked my video, don't forget to click the like button. If you have not already, subscribe to the Pat Has Your Back channel. As with most of my training videos, there are practice questions toward the end of the video. Before DNS, host files were used to map human-friendly host names to numerical IP addresses, which can be used to access the host and its services. The disadvantage of using host files is that you'll have to add entries for each name and IP address in the host file, and you'll have to update the host file on every system. The host file is a simple text file. In Windows, the host file is located at c:\system32/system32/drivers/etc/hosts. In Linux, the host file is located in the /etc/hosts. Comments start with the pound, which causes the system to ignore the line. While host files are not used much today, they come in handy when troubleshooting or testing solutions where you want to override the current DNS on the computer that has the host file. Domain Name System, or DNS, is used to resolve names to IP addresses. When you type in a URL in a browser or you try to connect to a server or computer, DNS will resolve the name of the server or computer to an IP address. DNS uses port 53. Early DNS used UDP, but more recent versions were upgraded with reliability, security, and privacy, which uses TCP. DNS uses fully qualified domain names, or FQDNs, to map a host name to an IP address. An FQDN describes the exact relationship between a host and its DNS domain. For example, computer1.sales.microsoft.com represents an FQDN where the computer1 host is located in the sales domain, which is located in the Microsoft second level domain, which is located in the .com top level domain. Because it's so closely tied to the internet and TCP/IP network, it's an essential service that enables the internet and network to function and is required by many network services, including Active Directory. DNS is often referred to as a lynchpin service, meaning it's a critical component that, if it fails, it can significantly impact the functionality of other services in the internet as a whole. Many applications and services rely on DNS to function correctly. If DNS fails, these services will likely be unable to connect to their servers, causing disruption. If you hear or see naming server, you should think DNS. DNS is a hierarchy distributed naming system used to locate computers and services on a TCP/IP network. DNS clients send queries to a DNS server, and the domain name system receives and resolves queries such as translating a host or domain name to an IP address. DNS is known as a distributed naming system because the information stored with DNS is not found on only a single DNS server. Instead, the information is distributed among multiple DNS servers, all of which are linked to a hierarchy structure. At the top of the tree is the root zone. The tree can then be divided into zones, each served by a named DNS server. Each zone can contain one domain or many domains. Administrative responsibility over a zone can be delegated or divided by creating a subdomain, which can be assigned to a different name server and administrative identity. A DNS domain is a logical division of the DNS namespace, usually a simple, human-readable name on the internet like example.com. A DNS zone is an administrative area within the DNS system that contains all of the DNS records associated with a specific domain, allowing for granular management of that domain's DNS settings. It includes information like IP addresses, mail server settings, and more. A zone and zone information is stored in a zone file. DNS is comprised logically of domains, but physically of zones. In most cases, the domain and DNS zone will have a one-to-one relationship. In the figure, the zones are Com, Microsoft, and Sales. Each has its own set of DNS administrative area that is listed separated from the other DNS zones, although they could be placed on the same server. In this case, Com is managed by VeriSign, but remains under ultimate jurisdiction of US law. Microsoft and Sales domains are managed by Microsoft. Computer 1 is the resource record in the Sales DNS domain and zone. The root name servers are the highest level DNS servers in the entire namespace, and they maintain information about the top level domains. After a computer attempts to resolve a DNS name, it begins at the top of the namespace hierarchy with the root name servers and works down the levels until it reaches the authoritative server for the domain in which the name is located. All DNS server implementations are pre-configured with the IP addresses of the root name servers because these servers are the ultimate source for all DNS information. They are sometimes referred to as root hints. If root servers change, which is not often, the root hints are typically updated within the operating system or device updates to reflect the change and is usually invisible to most users. Just beneath the root name servers are the top-level domains. The original DNS namespace called for 6 generic top-level domains dedicated to specific purposes as follows. Com is used for commercial organizations. EDU is for 4-year degree-granting educational institutions in North America. Gov is for United States government institutions. MIL is for United States military applications. Net is for networking organizations, and org is for non-commercial organizations. Eventually, other domains not tied to a country were added, such as Aero, Biz, Co-op, Info, Museum, Name, and Pro, followed by App, Tech, XYZ, Guru, Photography, and others. While you cannot purchase a top-level domain in the way individuals or organizations buy second-level domains, you can apply to become a registry operator for a new top-level domain, which is a complex and costly process governed by the Internet Corporations for Assigned Names and Numbers, or ICANN. In addition to the generic top-level domains, hundreds of two-level country code top-level domains exist named for specific countries in their own languages, such as FR for France and D for Deutschland or Germany. Two-letter codes for countries, territories, and other geographic entities are taken from the ISO 3166 standard published by the International Organization for Standardization. The site listed on the screen will show all of the two-level top-level domains. Note, TV is not short for television, but it's the country code for Tavala, which is a Polynesian island. TV domain is popular because many correlate TV with the television domain. Each top-level domain has its own collection of second-level domains. Individuals and organizations can purchase these domains for their own use. For example, the second-level domain contoso.com belongs to a company that purchased the name from one of the many internet registrars now in the business of selling domain names to consumers. For the payment of an annual fee, you can purchase the rights to a second-level domain. After you purchase the rights to a second-level domain, you can create as many hosts as you want in that domain by creating new resource records on the authoritative servers. You can also create as many additional domain levels as you want. For example, once you own the contoso.com domain, you can create the subdomains sale.contoso.com and marketing.contoso.com, and then populate these subdomains with resource records such as www.sales.contoso.com and ftp.marketing.contoso.com. The only limitations to the subdomains and hosts is you can create in your second-level domains are as follows. Each individual domain name can be no more than 63 characters long. The total FQDN, including the trailing period, can be no more than 255 characters long. The client checks to see if the name queried itself. The client then searches a local host file, which is a list of IP addresses and names stored on the local computer, and then looks for cached DNS records. The DNS record time to live has not expired. It will use the cache value. The computer will often cache resolved addresses to improve performance by reducing the need to repeatedly query upstream servers for the same host name. Even DNS servers will cache resolved addresses to improve performance. Next, the domain name system servers are queried. It will first check with the primary DNS server. It will only go to the secondary DNS server, which is used for redundancy if primary DNS server is not available. On the DNS server, it will check its own cache, followed by performing a direct search in its own DNS database. If the DNS server does not already know the answer, your primary DNS server will do an iterative query to find the correct DNS server. When the query is completed, the response will be added to the cached DNS server cache in the DNS cache of the client. The cache value will remain until the time to live or TTL of the record is reached. A DNS client sends a name resolution request to its designated DNS server. The DNS server is the authoritative for the domain, or it has the cached DNS value that the TTL for the resource record has not expired. It will respond with the answer. An iterative DNS query is a request for a website name or URL that will ask one DNS server for the address. If the server knows of the address, it will give the address. However, if it does not know the answer, it will give you a partial answer by giving you the address of the naming server or DNS server that will be more authoritative, which will get you one step closer to the complete answer. The client's DNS server sends an iterative query to a root name server. Since the DNS server does not know the necessary information, it will respond with the address to a top-level domain name server. The client's DNS server forwards an iterative query to the top-level domain, such as .com or .edu. Since the DNS server does not know the necessary information, it will respond with the address to a second-level domain naming server. The client's DNS server forwards an iterative query to a second-level domain server. If it knows the answer, it will respond to the original DNS server with the authoritative answer to the DNS query. Of course, if the query needs to access the subdomain DNS server, it will reply with the address of the subdomain DNS server. The client's DNS server will then respond to the client with the IP address for the host. In summary, DNS client will perform a recursive query to its designated DNS server. Client expects a complete answer. The DNS resolver or server takes full responsibility to resolve the query completely on behalf of the client. It does the work and reports back the final answer. If the resolver doesn't have the answer in its cache, it will query other DNS servers recursively until it finds the final answer. The client gets either the final resolved IP address or an error if resolution fails. The DNS server will perform iterative queries starting at the top level to perform queries until it finds the authoritative DNS server for the domain of the resource that you seek. In iterative queries, the client receives a referral, not the final answer. The DNS server responds with the best answer it has, either the final answer if it knows it, or a referral to another DNS server, the next level authoritative server. The client itself must continue querying the referred DNS servers. The authoritative DNS server will provide the complete answer to the query that is provided to the client's DNS server and provided to the client. Authoritative DNS servers is the primary source of information for a specific domain holding the definitive record of its IP address and other DNS records. Non-authoritative DNS servers does not hold the original zone files and instead relies on cached information retrieved from authoritative servers to respond to DNS queries. Essentially, the authoritative server is the only one with the absolute truth about a domain's information, while the non-authoritative server acts as a temporary cache for previously looked up data. Here is Microsoft's DNS with 2 forward lookup zones and 3 reverse lookup zones on the same DNS server. DNS zones can be divided into the following types. Forward lookup zone, which maps a domain name to an IP address. Forward lookup zones are the basis of what DNS servers do and are used for accessing websites, email services, and more. Reverse lookup zone maps an IP address to a domain name. Reverse lookup zones are useful for security and network troubleshooting and are often used by email servers to verify the authenticity of incoming emails. The resource record, or RR, is the unit information entry in the DNS zone files. Resource records are the basic building blocks of hostname and IP information and are used to resolve all DNS queries. Resource records come in a fairly wide variety of types in order to provide extended name resolution services. The most common DNS server resource records is the host or A record, which provides name resolution to IP address. If a client queries the first DNS listed in the IP configuration and that DNS server is not available, it will go to the secondary DNS server listed, if one is listed, in the IP configuration. If the second DNS server is not available, it will go to the next one if one is listed. It is recommended to have at least 2 DNS servers listed for redundancy. If it queries the first DNS server and the DNS server is active, it does not know the answer and it cannot determine the answer through iterative queries, it will respond with no host found and it will not query the second DNS server listed in the IP configuration. Again, it will only go to the secondary DNS server if the first DNS server is not available, not because it does not know the answer. Name caching enables the second name resolution request for the same name to bypass the referral process by saving the DNS information as recently retrieved into memory. The value will be cached until the TTL for the resource record is reached. DNS server caching is used to improve overall performance of DNS queries. DNS servers send recursive queries to other servers when you configure a server to function as a forwarder. On a network running several DNS servers, you may not want all the servers sending queries to other DNS servers on the internet. Instead, you would forward these requests to your ISP DNS server or a well-known public available DNS server. You configure forwarders to forward to another DNS server for name resolution. You can use your ISP DNS server or you can use a public external DNS server. Popular external DNS servers include the following. 8.8.8.8 and 8.8.4.4 are Google Domain Name System servers. 1.1.1.1 is Cloudflare Domain Name System, and 4.2.2.2 is Level 3 Communications, which is run by CenturyLink. Question: which file is used to map host names to IP addresses on a client computer? Answer: host. Question: today, what service is used to provide name resolution to an IP address? Answer: DNS. Question: when you type in a URL, what is the full name called? Answer: fully qualified domain name, or FQDN. Question: what port does DNS use? Answer: 53. Question: which of the following is the DNS feature that controls how long a lookup is stored in cache on a server? Answer: TTL. Question: a user is unable to navigate to a website because the provided URL is not resolving to the correct IP address. Other users are able to navigate to the intended website without issue. Which of the following is most likely causing the issue? Answer: host file. Remember, local host files are used before DNS cache or DNS queries. For more information, visit these sites. In summary, before DNS, host files were used to map human-friendly host names to numerical IP addresses, which can be used to access the host and its services. While host files are not used much today, they come in handy when troubleshooting or testing solutions where you want to override the current DNS on the computer that has the host file. Domain Name System, or DNS, is used to resolve names to IP addresses. DNS uses fully qualified domain names, or FQDNs, to map a host name to an IP address. DNS is a hierarchy distributed naming system used to locate computers and services on a TCP/IP network. The root name servers are the highest level DNS servers in the entire namespace, and they maintain information about the top level domains. An iterative DNS query is a request for a website name or URL that will ask one DNS server for the address, and if the DNS server does not know the answer, it will refer you to another DNS server that will get you closer to the authoritative DNS server. DNS zones can be divided into forward lookup zones and reverse lookup zones. The resource record, or RR, is a unit of information entry in the DNS zone files. Thank you for watching this video. The next video will be TCP/IP Part 14 DNS Resource Records. If you like this video, be sure to click the like button. And if you have not already, subscribe to the Pat Has Your Back channel. Thank you.